We organize our lives around the calendar. We know when spring arrives, when summer begins, and when new seasons start. But plants and pests don't follow calendars hanging on our walls. They follow different calendars. These calendars are known as biological calendars, shaped by temperatures, rainfalls, environmental conditions. Together, they tell plants when to grow and pests when to emerge. Unlike our calendars, nature never asks what month it is. It doesn't read dates, it reads signals. But what happens when these calendars change? When biological calendars change, timing changes. Plants respond, pests respond, and risks respond too. We often think that finding a problem is the hardest part. But in plant health, the real challenge is knowing that something has changed in the first place. So the question becomes, how do we know these changes are happening at all? How do we detect them before they become a larger problem? That simple idea leads to much bigger questions. So, some questions are better answered by experience. From years ago, some plant pests couldn't survive in certain regions. Today, some of them are spreading in places where they have never been reported before. How is climate change changing the map of plant pests around the world?
Over the past decades, climate change, together with increasing trade and the movement of plant material, is reshaping the distribution of plant pests and diseases worldwide. Rising temperature, changing in rainfall pattern, and shifts in environmental conditions are allowing some pests to survive, reproduce, and establish themselves in areas where they were previously unable to persist. As a result, we are witnessing significant changes in pest behavior and distribution.
Can you share some examples of plant pests that are now appearing in places where they were not previously considered a concern?
Some pests are appearing earlier in the season, remaining active for longer period, and expanding into new geographical areas. Well-known examples include fall armyworm, which spread rapidly from Americas to Africa, Asia, and the Near East, and negatively impacted maize production across these regions. Also, tomato leaf miner, which expanded beyond its original range and became a major threat to tomato production across Egypt and many other countries. Another notable example is the desert locust, whose outbreak has become more frequent and severe due to unusual weather pattern linked to climate variability, that enabling large swarms to develop and spread across large areas of Africa, Near East, and South Asia, and threatening food security and agricultural livelihoods. In Egypt, recurring outbreaks of fruit flies continue to pose challenges to fruit production and export systems. While date palm weevils remain one of the most destructive pests of date palms, demonstrating how invasive pests can threaten economically important crops that require sustained surveillance and early detection efforts.
If risks are changing, how do we know these changes are actually happening? And how are they detected before they become a larger problem?
In this rapidly changing environment, surveillance is more important than ever. Through field scouting, pest diagnosis, trapping system, digital technologies, surveillance provides the critical information needed to identify threats early, assess risks, and support informed decision making. Today, the systems play a crucial role in protecting crops, supporting farmers, enhancing resilience, and safeguarding food security through timely action and informed decision making. Timely reporting of pest observations allows information to be rapidly analyzed and transformed into actionable intelligence, enabling authorities and stakeholders to respond before problems escalate and adopt anticipatory actions. Effective surveillance goes beyond collecting data. It creates a vital link between the field and decision makers. Enhancing surveillance and the early warning system is therefore an investment in agricultural resilience and sustainable food systems.
So, the most dangerous pest is not the one we find. Sometimes it is the one we haven't noticed yet. That's why surveillance is one of the most important tools in plant health.
The benefits of surveillance extend far beyond agriculture. Emerging pest threats can affect biodiversity, disrupt the ecosystem, reduce crop productivity, increasing production costs, and ultimately impact food security and the national biosecurity.
As risks continue to change, surveillance must evolve as well. Today, new technologies are transforming the way we observe, detect, and respond.
Advances in digital technologies are further enhancing surveillance systems. Mobile applications, digital reporting platforms, geographic information systems, and data management tools enable real-time collection, sharing, and analysis of information. These innovations improve reporting mechanism, enhance situational awareness, and support faster and more coordinated proactive responses.
What role has FAO played in supporting surveillance, reporting, and early warning systems over the years?
For many years, FAO has supported national efforts to strengthen surveillance, reporting, and early warning systems through technical cooperations, developing digital platforms for data collections and information sharing, and also establishment of partnership with different national authorities. Surveillance today is protection for tomorrow. This principle lies at the heart of modern plant health systems and effective integrated pest management approaches.
And so, the most interesting thing about the future is that it rarely arrives the way we expect. That's why it's important to understand changes. And this understanding in plant health begins with surveillance and goes strongly through cooperation. Because protecting plants is a shared responsibility, and only one country cannot achieve it alone.